Okay, this is Mrs. A with a recap of the problem we covered the other day in class. So, you plan to cross a river and want to know how far it is to the other side. The other side, so what they're talking about is they want us to calculate this value over here, crossing over the river. And you take measurements on your side of the river and make the drawing shown. Explain why triangle ABC and DEC are similar. So remember, for two triangles to be similar, they need to have at least two angles that are the same, two angles that are congruent. So I'm looking at my two triangles, and I'm sure you can see them in the drawing. There's triangle DCE. Let's see. There we go, DCE. And then we have triangle ABC. ABC. So those are our two triangles, and we're looking for a pair of angles that are congruent. So I see that there's 90-degree angles, so there's one pair. So I can write down there's a pair of 90-degree angles. And I also noticed that there are two crossing lines, and I'll draw them over here. So there's one line that crosses with another line. Whenever we have two lines that are crossing with each other, those two angles that they make, the opposite angles, are called vertical angles. And vertical angles are congruent. So that's how we found our two angles, or two angle pairs, that prove that the two triangles are similar. So the 90-degree, and then there's a pair of vertical angles. And so that is why they are similar. So what is the distance x across the river? We know that the two triangles are similar, and so we can use them to find proportional distances. We can use them to find the distances of sides that are unknown. And the best way to do that is to draw out the two triangles and label them and find the missing distance and look for the proportionality. So if I have triangle 1, let's call the top one triangle 1. Let's call the bottom triangle triangle 2. Okay, I'm going to draw out the two triangles. So this will be my triangle 1. This side will have my triangle 2. And let's see, we got, just kind of split that up. And I know that my triangles have right angles, so they're right triangles. And so triangle 1 has a 90-degree angle, and it has a vertical angle, and that's over here. I'm trying to map it up to the drawing. Now, my second triangle, I have to rotate it clockwise to see this, but I can see that my 90-degree angle is here, and I can see the vertical angle is here. Now, the second step is I have to label the sides, and to label the sides, the best way to find those sides is to look at the angles and find the measures in between the angles. That helps give me a reference point. So, for example, I see that I have my 90-degree over here. I've got my vertical angle over here. So therefore, my 50 foot goes in between the 90 degrees and the vertical angle. So I'm going to write 50 feet down here. Oh, that's actually that's right, 50. And then I notice that the 60 foot is on another leg off of that 90. So I know I can put 60 over here. And now for my triangle 2, I see that between the vertical angle, let's get the purple back up, between that vertical angle and between the 90-degree, I can see that's where my 40 foot goes. So I write my 40 foot down there. See how I'm using the angles that I identified as reference points to rewrite out the sides and get it correct? And I see the X is also on the leg off of the 90, so that has to be over here. And now I'm ready to make my write out my proportional statement. So I have, let's see, remember we have to go compare, we have to make ratios of one side of one triangle to one side of the second triangle. So for my first triangle, it's 60, and my second triangle is x, and that's equal to, I'll go from my first triangle, it's 50, to my second triangle, it's 40. So it's 50 over 40. And then I solve. I'm going to solve using the butterfly method. So that would get me x, that would give me 50x, which is equal to 60 times 40. And then I just solve. 60 times 40 is 2400. Actually, let's take it step by step. Divided by 50. And that gets me to 5 goes into 24. 4 times 48. That's my answer. Why don't you give it a try for number C? What if the distance from A to B is 55 feet? So if we look at where that A to B is over here, and let's say instead of it being 60 feet, what if it was 55 feet? You give that a try.